Hello everyone, thank you for joining me today as we embark on a journey to explore the cutting-edge world of blockchain technology. We'll be diving deep into the fascinating realm of modular chains and their revolutionary impact on the blockchain landscape. Before we start, I'd like to talk about a vibrant and dynamic community called Dora Dōjō. Dora Dōjō is an open-source knowledge community focused on cutting-edge technologies such as encryption and Web3, co-built by hackers. Dora Dōjō regularly organizes and shares sessions in the form of live broadcasts, audio, and text. The topics covered include L1 and L2 consensus algorithms, architecture, and related content in GitHub repositories. Some of the specific topics covered include Scroll/Polygon zkEVM, Eigen's hybrid proof system, Starkware, Aztec, Optimism, Zkri, Aptos, Move, cryptography, including zero-knowledge proof, public key encryption, hash functions, and lattice ciphers, distributed systems, the Ethereum protocol stack, quantum computing and quantum information, and satellite communication and spacecraft system design. The Dora Dōjō community is constantly expanding and inviting new members to join. If you are interested in learning more about cutting-edge technologies and staying ahead of the curve, I encourage you to contact Dōjō at DoraDojo0 on Telegram and claim your bounty. The Dōjō welcomes proposals for new content, and they will fund and share it. So, whether you are an experienced developer or just starting out, Dora Dōjō is the perfect community to learn and grow alongside like-minded individuals. Join us today and let's explore the world of cutting-edge technologies together. Imagine a world where blockchain isn't just a technology, but a dynamic ecosystem that can adapt and evolve to meet ever-changing demands. That's precisely what we're going to delve into today, the concept of modular blockchain. A modular blockchain architecture empowers us to construct blockchain networks like never before. It's all about flexibility, scalability, and adaptability traits that are crucial as we chart the path to the future of blockchain technology. Today, we're embarking on a journey into the exciting realm of blockchain technology. I'm thrilled to take you through the intricacies of a concept that's shaping the future of digital transactions, modular blockchain, and shed light on the innovative Celestia data availability layer. You might be wondering, why should we delve into modular blockchain and Celestia's data availability layer? Well, my friends, the blockchain ecosystem is constantly evolving. It's more than just cryptocurrencies, it's a foundation for secure and transparent transactions across industries. Understanding these emerging concepts isn't just an option anymore, it's a necessity. Our digital world relies on robust, efficient, and scalable blockchain systems, and that's where modularity and Celestia come into play. To navigate this complex landscape, we need to equip ourselves with knowledge of the key concepts and foundational principles that underpin these technologies. The references provided are like guiding stars in this vast universe of information. They offer insights into modular blockchain architecture and Celestia's data availability layer. These references are not mere reading materials, they are our pathway to unlocking the potential of these innovations. But that's not all. While the provided references are essential stepping stones, the world of knowledge is boundless. Feel free to explore beyond the boundaries of these references. So, let's embrace this learning opportunity. Let's journey together through the fascinating concepts of modular blockchain and Celestia's data availability layer. By the end of this exploration, you'll be equipped with insights that will not only enrich your understanding of blockchain but also empower you to envision the future possibilities of this groundbreaking technology. Let's dive into the very essence of our topic: modular blockchain. But what exactly is a modular blockchain, and why does it matter? Modular blockchain is a revolutionary design approach that treats blockchain as a collection of independent, specialized modules or components. These modules can be customized and assembled to create a blockchain network tailored to specific use cases. The significance of this concept cannot be overstated. But it brings unprecedented flexibility, scalability, and adaptability to the world of blockchain technology. Imagine building a blockchain like you would assemble Lego bricks, with each piece serving a specific purpose. Now, let's journey through the historical development of modular blockchain architecture. Modular blockchain, in its early stages, was a response to the limitations of monolithic blockchains, which had inherent scalability issues and lacked adaptability. The concept of modular blockchain is not just a technicality, it's a fundamental shift in how we think about and build blockchain networks. Its significance lies in its ability to address many of the challenges faced by traditional blockchains. As we continue our journey, we'll explore how this modularity impacts real-world applications and the blockchain ecosystem as a whole. Now that we have a good grasp of what modular blockchain is, let's compare it with two other prominent blockchain ecosystems, Cosmos and Polkadot. First, a brief overview of Cosmos and Polkadot. Cosmos and Polkadot are both blockchain ecosystems designed to facilitate interoperability among multiple blockchains. They aim to create a connected, multi-chain universe. But what distinguishes modular blockchain from these ecosystems? The core difference lies in the architecture. While Cosmos and Polkadot are designed as interconnected networks of sovereign blockchains, modular blockchain takes a different approach. So, what unique features does modular blockchain bring to the table? First, customizability. In a modular blockchain, you can assemble and configure different modules to create a blockchain network tailored to specific needs. This flexibility allows for efficient resource allocation and adaptability. Second, scalability. Modular blockchains often implement sharding as a means to scale. This means that transactions and smart contracts can be processed in parallel, significantly increasing throughput. Third, consensus mechanisms. Modular blockchains offer the flexibility to choose and implement consensus algorithms that suit the network's requirements. This is in contrast to Cosmos and Polkadot, which may have a fixed consensus mechanism. Fourth, interoperability. While Cosmos and Polkadot focus on connecting independent blockchains, modular blockchains can incorporate interoperability features as needed. This adaptability can simplify cross-chain communication. Lastly, governance. Modular blockchains often empower participants to make governance decisions at different levels of the network. This can lead to more decentralized and community-driven governance models. While Cosmos and Polkadot are pioneering cross-chain interoperability, modular blockchain stands out for its customizability, scalability, consensus flexibility, interoperability, adaptability, and governance diversity. Understanding these differences will help us appreciate the unique strengths and trade-offs of modular blockchain in various real-world scenarios. Now that we have a clear understanding of what modular blockchain is, let's explore the numerous advantages it brings to the table. Let's begin by enumerating the advantages offered by a modular blockchain architecture. 1. Customizability. One of the most significant advantages is customizability. In a modular blockchain, we have the flexibility to assemble and configure different modules to create a blockchain network tailored to our specific needs. 2. Scalability. Modular blockchains often implement sharding, which allows transactions and smart contracts to be processed in parallel. This significantly increases the network's throughput, making it more scalable. 3. Consensus flexibility. Unlike some other blockchain ecosystems, modular blockchains offer the freedom to choose and implement consensus algorithms that best suit the network's requirements. 4. Interoperability, adaptability. While interoperability is a focus of many blockchains, modular blockchains can incorporate interoperability features as needed. This adaptability simplifies cross-chain communication. 5. Governance diversity. Modular blockchains often empower participants to make governance decisions at different levels of the network. This decentralization leads to more community-driven governance models. Let's delve deeper into how modularity enhances scalability. In a modular blockchain, each component can be designed and optimized for specific tasks. For example, one module can handle transaction processing, another can focus on smart contract execution, and yet another can manage consensus. This specialization allows for parallel processing, greatly improving the network's scalability. Next, let's discuss how modularity enhances interoperability. Modular blockchains can easily integrate with external systems and other blockchains by simply adding the required modules. This adaptability simplifies cross-chain communication, making it easier for different blockchain networks to interact seamlessly. Adaptability is another key advantage of modular blockchain. If the network's needs change or new technology emerges, it's easier to swap out or upgrade specific modules rather than overhauling the entire blockchain. This ensures that the blockchain remains adaptable and future-proof. To illustrate how modularity facilitates the integration of specialized components, let's consider an example. Imagine a healthcare blockchain. With modularity, we can seamlessly integrate specialized modules for medical records, insurance claims, and supply chain tracking. Each module can be designed to efficiently handle its specific task, resulting in a more robust and efficient healthcare blockchain. Modular blockchain offers a plethora of advantages, including customizability, scalability, consensus flexibility, interoperability adaptability, and governance diversity. These advantages make it a compelling choice for a wide range of applications, from finance and healthcare to supply chain management and beyond. Now, let's dive into the fascinating world of the Celestia data availability (DA) layer, a pivotal component within the modular blockchain framework. First, let's define what the Celestia data availability (DA) layer is and understand its role within the blockchain. The Celestia data availability (DA) layer serves as a critical component in a modular blockchain. It is responsible for ensuring that data generated within the blockchain is not only available but also maintains its integrity. The primary purpose of the DA layer is to ensure data availability and integrity. In the world of blockchain, data is at the heart of every transaction and operation. Without proper data availability and integrity, the entire system can become unreliable and open to manipulation. Now, let's delve into the specific implementation theories that underpin Celestia's DA layer. The Celestia DA layer employs advanced cryptographic techniques to distribute data across the network securely. It uses a combination of encryption and redundancy to protect data from loss or tampering. Workflow of data availability using Celestia's approach. To better understand how the Celestia DA layer functions, let's walk through the workflow of data availability using Celestia's approach. 1. Data generation. The process begins with the generation of data within the blockchain. This can include transactions, smart contract outputs, and other blockchain-related data. 2. Data fragmentation. Celestia's DA layer fragments this data into smaller, manageable pieces. These fragments are distributed across the network. 3. Redundancy and encryption. The fragments are duplicated multiple times across different nodes in the network to ensure redundancy. Each fragment is also encrypted to protect its integrity. 4. Data retrieval. When a user or node needs access to this data, they can retrieve the necessary fragments from various nodes. 5. Reconstruction. The user's software reconstructs the original data by combining the retrieved fragments. This process ensures that the data remains available even if some nodes go offline or become unresponsive. The Celestia data availability (DA) layer plays a vital role in ensuring the availability and integrity of data within a modular blockchain. Through advanced cryptographic techniques and a distributed approach to data storage, Celestia's DA layer enhances the reliability and security of blockchain transactions and operations. Now, let's compare two innovative approaches to data availability within blockchain, Celestia's DA layer and Danksharding. To begin, let's provide an overview of Danksharding's data availability mechanism. Danksharding introduces a data sharding approach that divides blockchain data into smaller, more manageable parts, called shards. These shards are distributed across a network of nodes, with each node responsible for storing a portion of the data. Next, let's highlight key similarities and differences between Celestia's DA layer and Danksharding. Both Celestia's DA layer and Danksharding focus on ensuring data availability and integrity within a blockchain network. They achieve this by distributing data across multiple nodes, reducing the risk of data loss or tampering. However, there are notable differences. Implementation approach: Celestia uses fragmentation and encryption of data, while Danksharding relies on sharding data into smaller segments. Celestia reconstructs data by retrieving fragments from multiple nodes. In Danksharding, data reconstruction typically involves collecting shards from various nodes. The security mechanisms employed by both approaches may differ. Celestia emphasizes encryption for data protection, while Danksharding may have its own set of security features tailored to its sharding method. Now, let's discuss the potential strengths and weaknesses of each approach in different scenarios. Celestia's approach of data fragmentation and encryption provides robust data security and protection against tampering. The method of fragment retrieval ensures data availability even if some nodes are offline or unresponsive. This approach is particularly suitable for use cases where data integrity and confidentiality are paramount, such as healthcare or finance. The process of data fragmentation and encryption may introduce higher computational overhead and complexity. It may not be as resource efficient in scenarios where rapid data retrieval and processing are crucial. Danksharding's sharding mechanism can enhance scalability significantly, allowing for high-throughput transactions and data processing. In scenarios where quick data access is critical, Danksharding's approach of dividing data into shards may offer advantages. It might be well-suited for applications that require massive parallel processing, such as decentralized applications, dApps, with high transaction volumes. Sharding introduces additional complexity, especially in terms of managing and coordinating data across multiple shards. Ensuring data availability across numerous shards can be a challenge, and data reconstruction may become cumbersome in the case of a large number of shards. Celestia's DA layer and Danksharding represent innovative solutions to address data availability and integrity within blockchain networks. The choice between the two approaches depends on the specific requirements and priorities of a given blockchain application. Celestia's focus on data security and availability through fragmentation and encryption may be preferred in scenarios where data confidentiality and trust are paramount. On the other hand, Danksharding's sharding approach may excel in use cases where scalability and rapid data access are critical. In the world of blockchain, data availability is a critical challenge, especially in permissionless networks where trust is minimal. Today, we'll explore how Celestia's data availability (DA) layer provides a scalable solution to this crucial issue. First, let's understand why data availability is a significant concern in blockchain networks. In permissionless blockchains, anyone can join as a node, which makes it essential to ensure that data is available for all participants. Without this assurance, transactions and operations become unreliable. Celestia's DA layer introduces two key features that address the data availability problem: data availability sampling (DAS) and namespaced Merkle trees (NMTs). Let's start with data availability sampling (DAS). The DAS allows light nodes to verify data availability without downloading an entire block. Instead, Celestia uses a two-dimensional Reed-Solomon encoding scheme to encode block data, splitting it into smaller chunks organized in a matrix. To implement DAS, Celestia extends this matrix with parity data, creating an extended matrix. From this extended matrix, multiple Merkle roots are computed for rows and columns, and the Merkle root of these Merkle roots is used as the block data commitment in the block header. Light nodes randomly select unique coordinates within the extended matrix and query full nodes for data chunks and corresponding Merkle proofs at those coordinates. If light nodes receive valid responses for each sampling query, there's a high probability guarantee that the whole block's data is available. Additionally, every received data chunk with a correct Merkle proof is shared across the network. As long as Celestia light nodes collectively sample enough data chunks, the full block can be recovered by honest full nodes. DOS is a crucial component of Celestia's scalability. Since each light node samples only a small portion of block data, it can be performed by resource-limited nodes. The more light nodes that participate, the more data they can collectively download and store. Increasing the number of light nodes performing DAS allows for larger blocks with more transactions while still keeping DAS feasible for resource-limited nodes. Moreover, any improvement in the bandwidth capacity of Celestia light nodes has a quadratic effect on the throughput of Celestia's DA layer. However, Celestia's two-dimensional Reed-Solomon encoding requires downloading the 4K intermediate Merkle roots. This is due to a potential challenge: malicious block producers generating the extended data incorrectly. As an alternative, DAS could be designed with standard dimensional Reed-Solomon encoding, where the data is split into K chunks and extended with K additional parity chunks. To address malicious behavior, fraud proofs of incorrectly generated extended data are employed. These proofs enable light nodes to reject blocks with invalid extended data. Celestia's data availability layer, with its innovative features like DAS and NMTs, ensures the availability and integrity of data within the blockchain. It offers scalability, robust security, and the means to handle malicious actors effectively. These advancements bring us closer to a future where blockchain networks can scale efficiently while maintaining trust and reliability. Now, let's explore one of the ingenious innovations within Celestia's data availability layer: namespaced Merkle trees, or NMTs. Celestia takes a unique approach by partitioning block data into multiple namespaces. Each namespace is designated for a specific application, such as a rollup. By doing this, Celestia ensures that every application only needs to download its own data and can safely ignore the data of other applications. To make this partitioning work seamlessly, Celestia's DA layer must be able to prove that the provided data is complete. In other words, all the data for a given namespace must be returned without exceptions. An NMT is a specialized Merkle tree where the leaf nodes are ordered by namespace identifiers. The hash function is also modified so that every node in the tree includes the range of namespaces of all its descendants. To illustrate this concept, consider the following example of an NMT with a height of 3, representing 8 data chunks. The data is divided into 3 namespaces. Now, let's say an application requests the data for a specific namespace, for instance, namespace 2. The DA layer must provide not only the data chunks relevant to namespace 2, D3, D4, D5, and D6, but also the nodes N2, N8, and N7 as proof. It's important to note that the application already possesses the root node N14 from the block header. With this data and proof in hand, the application can verify 2 critical aspects. First, it can confirm that the provided data is indeed part of the block data, ensuring data integrity and reliability. Second, the application can ascertain that all the data for its specified namespace, in this case, namespace 2, has been provided. Importantly, if the DA layer were to provide, for example, only data chunks D4 and D5, it would also need to supply nodes N12 and N11 as proofs. Why? Because these nodes contain descendants that are part of namespace 2. Incomplete data would become apparent when the application checks the namespace range of these nodes. Namespaced Merkle trees, NMTs, are a cornerstone of Celestia's data availability layer. They enable the partitioning of block data into namespaces, providing a way to prove data completeness for specific applications. NMTs ensure that blockchain applications can trust the data they receive, promoting trust and reliability within the network. In the intricate world of blockchain architecture, understanding how different layers function and interact is essential. In the intricate world of blockchain architecture, understanding how different layers function and interact is essential. Today, we'll break down the layers of a modular blockchain and explore how Celestia's data availability (DA) layer collaborates with the rollup mechanism for enhanced efficiency and security. A modular blockchain typically comprises several layers, each with its unique functionality. 1. Consensus layer. This layer is responsible for achieving agreement among network participants. It defines the rules for validating transactions and adding them to the blockchain. 2. Data layer. Here, data is stored securely and redundantly. It ensures data availability and integrity, crucial for trust in blockchain networks. 3. Execution layer. This layer manages smart contracts and decentralized applications, dApps. It executes code and processes transactions. Now, let's delve into how the Celestia DA layer interacts with the Rollup mechanism. The DA layer in Celestia focuses on ensuring data availability and integrity. It utilizes innovative techniques like data availability sampling, DAS, and namespaced Merkle trees, NMTs, to achieve this. Rollup, on the other hand, is a layer 2 scaling solution that aggregates transactions off-chain and submits a single proof on-chain. It significantly enhances blockchain scalability. The Celestia DA layer and Rollup work collaboratively to enhance the overall efficiency and security of the blockchain. Rollup benefits from Celestia's DA layer by leveraging its data availability features. Rollup can offload transaction data to the DA layer, ensuring that the data is available without compromising the efficiency of the main blockchain. By using the DA layer, Rollup makes the blockchain more efficient. It reduces the congestion on the main chain by aggregating transactions off-chain. While enhancing efficiency, this collaboration doesn't compromise security. The DA layer guarantees that the data needed for Rollup transactions is available and trustworthy, crucial for maintaining the blockchain's security and reliability. Understanding the functionalities of each layer within a modular blockchain is key to appreciating how Celestia's data availability (DA) layer enhances security and efficiency. When combined with the Rollup mechanism, the DA layer provides a powerful synergy, improving scalability and ensuring data reliability without compromising the blockchain's security. It's a testament to the power of collaboration within blockchain architecture. The modular approach, where each layer plays a distinct role, allows for innovation and scalability while maintaining trust in the network. Let's embark on a journey into the future of public chain development. For all the bounty applicants out there, this is your chance to dive deep into the evolving landscape of blockchain technology. First and foremost, I encourage all bounty applicants to embrace the role of analysts in the blockchain space. Being an analyst means keeping a keen eye on trends, understanding emerging technologies, and deciphering the implications for the public chain ecosystem. So, what are the trends that we should be watching for in the world of public chain development? 1. Advancements in consensus algorithms. Expect to see innovations in consensus mechanisms, including proof-of-stake, POS, sharding, and hybrid models. These changes will aim to enhance security, scalability, and energy efficiency. 2. Scalability solutions. With the growing demand for blockchain applications, scaling solutions like Layer 2 protocols and sidechains will continue to evolve. The focus will be on improving transaction throughput and reducing fees. 3. Interoperability protocols. The ability of different blockchains to communicate seamlessly will be a hot topic. Interoperability protocols will play a pivotal role in connecting disparate blockchain networks. Let's dive deeper into these potential future directions. Public chains may experiment with novel consensus algorithms that prioritize energy efficiency and security. This could lead to more widespread adoption as environmental concerns come to the forefront. Layer 2 scaling solutions, such as state channels and rollups, may evolve to handle even higher transaction volumes. These solutions could become the backbone of decentralized applications, making them faster and more cost-effective. The blockchain ecosystem may see the emergence of universal interoperability protocols that allow seamless communication between different chains. This could enable cross-chain DeFi, NFTs, and more. As we look ahead, it's crucial to acknowledge the persisting challenges that the blockchain ecosystem needs to address. 1. Scalability bottlenecks. While progress is being made, scaling remains a challenge, especially for highly congested networks. Finding sustainable, long-term solutions is paramount. 2. Regulatory uncertainty. Blockchain technology operates in a rapidly changing regulatory landscape. Navigating these uncertainties while ensuring compliance is an ongoing challenge. 3. As blockchain adoption grows, so does the interest of malicious actors. Enhancing security mechanisms to protect against evolving threats is an ongoing battle. As we analyze the future trends and challenges in public chain development, remember that the blockchain space is dynamic, ever-evolving, and ripe with opportunities. As we draw this presentation to a close, let's recap the key points we've explored today and reflect on the significance of modular blockchain and Celestia's data availability (DA) layer. We began our journey by unraveling the intricate world of modular blockchain, tracing its historical development, and distinguishing its unique advantages. We delved into the critical differences between modular blockchains and other ecosystems like Cosmos and Polkadot, showcasing how modularity can pave the way for innovation. We then dissected Celestia's DA layer, uncovering its role in ensuring data availability and integrity within the blockchain. Our comparison with Danksharding shed light on different approaches to tackling the same challenge. Moving forward, we explored the collaborative functionality of the blockchain's layers and how Celestia's DA layer seamlessly interacts with the Rollup mechanism, enhancing efficiency and security. Lastly, it's crucial to reiterate the importance of understanding modular blockchain and its components. In a rapidly evolving blockchain landscape, knowledge is the cornerstone of progress. By grasping the intricacies of modular blockchain, we empower ourselves to innovate and contribute to its growth. Celestia's data availability (DA) layer stands as a testament to innovation in the blockchain world. IT not only ensures data availability and integrity but also opens doors to new possibilities for scalability and security. As we conclude, I encourage each one of you to continue your exploration of the evolving blockchain landscape. Keep an eye on trends, dive into research, and actively engage with the blockchain community. Your insights and contributions are integral to shaping the future of this transformative technology. Thank you for your time and attention today.